Hello, today we're looking at surface area of cuboids. Now just a very quick reminder as to what a cuboid is. A cuboid is a 3D shape where all 6 of the faces are rectangles. Okay, so here is one visual representation of the cuboid. Now when you look at this drawing, you can see that the first face there is clearly a rectangle. However, the other faces, because it's a 2D drawing of a 3D shape, are skewed. But we know, because we're told it's cuboids, all the faces are rectangles. With a cuboid, we have 3 dimensions. So the base, width, height, or length, width, height. And we can be given these or we can measure these. Cuboids come in many different shapes and sizes, but essentially these are all faces are rectangles. So what I've got here is I've got a stock cube box. Other brands are available. And what I'm going to do is I'm going to calculate the surface area of this stock cube box, i.e. how much space each of the 6 faces takes up. So the total area of all 6 faces. So to start, I'm going to open it up. Scissors. Now, because this is a practical box, it's got flaps on it, and these flaps are what helps keep the stock cubes inside the box. Because we only want to know the outside of the whole box rather than the whole box and the flaps, what I'm going to do is I'm going to carefully cut the flaps off. But note, I am not cutting off the actual faces of the box. Okay, so that's those gone there. So you can see that if I was to fold the box back over, it would still make that cuboid, but it would no longer be able to hold still because I've removed the flaps. These are going to go into the recycling later. Now let's have a closer look at this box. Okay, now when I flatten out the shape, we get the net of the cuboid. And with cuboids, the shapes always come in pairs. So when we look carefully, we can see that this face here is the same as this face up here. And we can see that this face here is the same as this face here. Oops, she says going off the paper. There we go. And the final face here is the same as this face here. Now, when I fold the cuboid back up, we will find that opposite faces are equal on a cuboid. So, fold this back up. We can see, obviously I'm holding it, it won't stay because I've removed the flaps. That face there and that face there are the same. Move it over so we can see it a bit clearer. Oops, there it goes. That face there. I've just spotted the dirt in my thumbnail where I've been doing the tomatoes this morning. Great. And that face there are the same. Sorry, I'm digressing off the maths. And this face here and this face here are the same. So if you've got your box, you can do the same thing on your cuboid. Hold on. Excuse me. Do the same thing on your cuboid, so you can clearly see that these dimensions are, these are the same These are the same, and these are the same. Pause your video while you do that. Okay, now obviously your box, your cuboid is going to look slightly different to mine because you've got different cuboids. But this one here, what I'm going to do now is I'm going to measure and I'm going to find the dimensions of this cuboid. So let's move this over so I can get it on my page and move that over so it's all on screen. Right, okay, so when I measure it, I'm just going to measure it to the closest centimetre so that it's easy for me to do the calculation. Now all of these are calculator questions, okay, so you can use your calculator on them if you want to record it to a point of a centimetre, tenth of a centimetre, that's absolutely fine. I'm just going to do it to a whole centimetre for ease. Okay, so this first one here, this dimension here is 6 centimetres. That comes out, I'm going to put that as 2 centimetres because I'm rounding it to the nearest centimetre. 6 centimetres. Two centimetres. Ooh, I haven't measured that bit there. Actually, both of those are 2 centimetres. 12 centimetres. There we go. So that's me measured all of the dimensions of my box. But if you'll notice here, this here is 2 and this here is also 2. Likewise, we've got this 6262 pattern forming. Now the reason for this is because of folding it back up. When we fold it, if we look at this corner here, that corner must join, hang on, let's move that into view. That corner must join with that corner. So therefore, both of those must be the same measurement. And again, because we know when we fold it, this face here is the same as this face here. Therefore, we know if that is 6, that is 6. Okay? Put this back down here. If we refer back to our original diagram here, on this they will often show the dimensions, but you've got to be able to interpret from this to this to this. So this longest side here is 12 centimetres. The side going back, now because it's in perspective, it reduces the length of it. I am telling you this is 6 centimetres. We know that if I was to get a ruler and measure this, it wouldn't be 6 centimetres. But because this is a 2D representation of the 3D shape, it looks smaller. And again, the height is 2 centimetres. Again, because of it's not in proportion, it's distorted, but we know from the diagram this is what this means. Okay? Right, so coming back to here, we now have 6 rectangles. And what you need to do is you need to calculate the area of each of these 6 rectangles. So, this first one here. When we calculate the area of a rectangle, it's base times height. So if the base is 6, this one here, now we don't know the height of this. I haven't measured this green height here, but I've measured the green height over here. She says moving the click over so we can just see it. It's 12 centimetres, so we've got 2 times 12 gives us, I'm going to have to write that underneath. Oh, I've just realised I'm supposed to be colour coding and I haven't. Ah, drat. Oh well, we can see it clearly. And the last one I need to do, oops, the one down here, this is 2 centimetres. 2 times 6 is 12 centimetres squared. However, because these are in pairs, without doing any calculation, if that is 12, that must be 12. If that is 24, and I will colour code it now. Green circle around there. There I was trying to get it all beautifully colour coded. Ho hum. And we know that if this is 72, that must also be 72 centimetres squared. So to recap, I've colour coded and then I've worked out the area of each of these shapes. Okay, pause the video and work out the area for your cuboid. Once I've got all 6 areas, surface area is the area of the net or the area of the total surface of the shape. Okay, this is why I haven't stuck mine down yet, so that I can refold it. It sits in back there. So we know we have to add up the 6 faces together. So we've got 2 lots of 72. We have 2 lots of 24. And we have 2 lots of 12. Now, like I say, this is a calculator paper, but anytime we have any calculator questions, what you must always do is jot down what calculations you are putting into the calculator. That way we know what method you've used. So I've got 72, 72, 24 and 24, 12 and 12. So for the cuboid, I've got the 6 faces. Add that all up, pause the video, add that all up and see what I've got on mine and see what you've got on yours. Okay, you should come out with 116 centimetres squared. Okay, now this is the surface area of this cuboid. The other thing to note that these types of questions are normally 3 or 4 marks. Blue tack stuck to that. Depending on the complexity of the question. So we're not expecting you to be able to do this in one simple calculation. It's difficult because although each calculation is relatively easy, you've got to remember what you've got to do in which order. So to recap, I've got my cuboid, I've flattened it out, and I've colour coded the pairs of faces. I've measured the dimensions of each of the faces and written it down. I've then calculated the area of each of the rectangles separately. So every time I did this, I came to a new calculation. But because those 2 are the same, I could do those 2 together. Those 2 are the same, I can do those 2 together. And those 2 are the same, so I can do those 2 together. Once I've found that, that gets me to about 2 or 3 marks depending on the complexity of the calculation. You then need to add them all together to get to the surface area of the cuboid. Okay, right, do that again and again for as many boxes as you've got, as many cuboids as you've got. Measure, check, and remember they are all calculator questions.